All right, next, let's do SO2. Right? Doesn't that look sort of similar in a way to H2O or maybe even CO2? So maybe you think that they might be similar. Well, CO2 ended up being that. And H2O ended up being that. What's SO2 going to be? Well, let's look. Sulfur, 1 times 6 electrons, right? Because it's in group 6A. But so is oxygen. 6 plus 12 is 18 divided by 2. We got 9 pairs here. 9 pairs we have to mess with. Sulfur's in the middle. Oxygens are attached. Single bonds between the center and the outer make the outers happy. 3, 4, 5, 6, 7, 8. Great, outers are happy. But we need to use 9 pairs. We've only used 8 so far. So that means there's 9. Is everybody happy? Let's do a quick count. This oxygen has 2, 4, 6, 8. Happy. This oxygen, notice that the entire bond feels like it belongs to the oxygen whenever we're counting for oxygen. 2, 4, 6, 8. Done. What about that center sulfur? I only see 2, 4, 6, right? 2, 4, 6. That's not 8, that's 6. So we have to do something. And we can't add extra electrons because we've already used up our 9 pairs. That's where double bonds come in, right? So how will we do that? Which oxygen? Well, pretend that I'm the sulfur. And this is one oxygen, and this is the other oxygen. I'll do it like this. If I decided to make this one a double bond and this is a single by sharing, and then I just turned around, it's the same molecule, right? Even though it looks like the other one is sharing. So what does that mean? It means it doesn't matter which one. It doesn't matter which one. You can pick whichever lone pair you want to contribute, as long as you keep track and make sure that everybody has their correct number of electron pairs. So this oxygen ends up being that. The lone pair stays on the sulfur, and now we're going to make a double bond on this oxygen. This oxygen still has 2, 4, 6, 8, right? This oxygen now has 2, 4, 6, 8. It's sharing not 1 electron pair, but 2. And now this center sulfur has 2, 4, 6, 8. That's it. That is the Lewis dot structure. It's different because it started with a different number of electron pairs, but you can still make them arranged around the center atom so that everybody's happy. So that center sulfur is pretty different because it's got a single bond and a double bond and a lone pair, as opposed to 2 double bonds on that center, 2 single bonds, 2 lone pairs on that. It turns out when we go and start to look at shapes of molecules, that the environment around the center atom is what determines the shape. And that's what we'll deal with when we get there. I just got 2 more examples for you. And this hopefully has another tie-in back to everybody's favorite chapter, favorite module, which is module 3. So let's go and take a look at a couple more Lewis dot structures.